Hi, I'm Andrew, and our project utilizes Socket.io and GetStream API that allows us to send up to 2 kilobytes of data per server request completely free. When users sign up to the client, their data is sent to the GetStream API, and in return they receive a proper token. Our project is extremely lightweight and has very few dependencies, only requiring React.js and Node to be installed. Anyone can download source files and begin playing against others who are running the program, given that they have matching API keys to do the server calls. This is very nice because we don't have to have a centralized database or server to manage all the requests. Anyone can do it peer-to-peer without anything in between. Every user is running the same program that emits data and receives it. We leverage the cookies we set at login to uniquely identify the client when displaying boards in appropriately discerning turns. The following games are our exploration of client-to-client interactions, and Zach will now showcase them.
In some of the following clips, you will see Andrew and I playing together some of our games across clients. I am playing on my computer and I am seeing Drew's screen across his Discord as he is streaming it to me. The background footage is of Drew and I playing Pentago. Pentago is like Connect 4 but requires 5 pieces in a row to win in a 6x6 grid, and you can rotate one of the corner 3x3 quadrants after each move. If a quadrant has rotational symmetry, then rotating it will do nothing, and thus you are not required to rotate after a move if such a quadrant exists. This presents unique linear algebra problems of symmetry in the subgrids and rotating submatrices. This was the first game we added to our arcade just to see if the API we were using would work for our purposes. We lock each client to a color after the first move is played by seeing who is the first person to send and receive data in the channel. After Pentago, I decided that animations would be the best way to elevate our games, so I started Battle Game. Battle Game has you pit your party of units against random enemies for 5 enemies per stage with 4 stages and a shot between each stage. For those of you who don't know, React only re-renders the page when the state variables change, so getting an animation to render a new frame without any state variables changing every fraction of a second sounded like a difficult task. I thought I would actually have an easy time though importing someone else's sprite component to use with React, as this must be a common thing, but I ended up setting out on a many-hour journey to create my own reusable sprite component, as all the ones I found were out of date. The asset editing and management was a nightmare, with 3 different sprite sheets for each unit I added, and trying to find similarly sized sprites for free online that look close enough alike to use together is actually quite difficult. Now that we've seen a few of the animations, let's see a run make it to the end. In this really fast clip here, in this second shop, I end up picking up a really good human unit that I am able to get to level 4 pretty early on and get some really strong items, allowing me to clear the final stage with ease. Next, we are interested in taking further advantage of our grid-based games and affecting multiple cells with a single click. Lights Out is a game where a fresh board of varying sizes has a random set of lights turned on to yellow. The goal is to turn off all the lights by clicking cells that will invert the state in a plus fashion. You can change difficulties by selecting different grid sizes, and we track the number of clicks and time it takes to solve. If you get stuck, the hint button will play one of the required moves to finish the game. For the sake of time, let's just say that this button is much more complicated than it looks. Here is some painful footage of me trying to solve a 5x5. At this point, we had an idea for a final game to tie in what we've learned, but we needed one more puzzle piece, so we developed Tic-Tac-Toe. Tic-Tac-Toe is exactly what you'd expect gameplay-wise. When we were tracking players through colors in the first click in Pentago, it made it impossible to display things with the player's name. So, we set out to use an easier game to test pulling player names from the channels to control the state. We can see here that the player who loses goes first in the next game, while accurately awarding points to the correct winner. Mega Tic-Tac-Toe is a 4-dimensional array representing 9 smaller tic-tac-toe boards brought together. To place a tile in the giant board, you must win a game in one of the smaller boards. Where you place a tile in a small grid determines which quadrant must be played in the bigger board for the next move. Now let's say that you are placing a tile in the top left corner of the small grid. That means the next player must play in the top left small grid of the bigger board, unless the top left grid is no longer playable. Then the next move can be made in any board that they want. Since the outer board ended up being a 4D array, this is the first time we ran into our 2 kilobyte size limit. This is where we learned to minimize data sent and make robust functions that would validate the signal sent and execute the proper functions to remain in sync with the enemy board. Mega Tic-Tac-Toe greatly improved our knowledge of what data we have to work with inside the channels. Here's a quick clip of Drew and I playing Mega Tic-Tac-Toe. The culmination of our learning experiences resulted in the final game, Battleship. Andrew set up the room so that player 1 and player 2 would be set upon entering the rooms, which was expedited by his experience with Mega Tic-Tac-Toe. I heavily leveraged the new sprite sheet component I had come up with from Battle Game to make our board look like water. For those of you who don't know, Battleship is a game where you simply set your ships on your own board and your enemy sets their ships on theirs and you cannot see them and you take turns calling out shots and you tell each other if you hit or not. The experience from Lights Out made affecting multiple tiles on our board much simpler when planning out where the ships should go. But I hit a funny snag during this section, making the cursor look like a placeable ship. Apparently Chrome's cursor cannot be over 128 pixels, which took me hours to figure out as the smallest ship was under 128 and was working. I also ran into the size limit here as each cell on the board had data for if it was hit, occupied by a ship, type of ship, and ship rotation with good variable names. I managed to go from 5600 bytes to 1600 bytes by changing this to just the cell's type and rotation and calling them X and Y. We had a lot of fun making all these different games and have gotten distracted many times by playing them. Thank you so much for watching and we hope you enjoy this final clip of us playing through Battleship.